operated underwater vehicle. It's got little thrusters and it's able to maneuver around. And then you can add sonar to be able to get to something because visibility is usually poor. Then am I just looking at it with my camera, or do I want to do something to it? So now we got little arms, you can come up and grab a hold of something. Black box, for example. So we're this delivery mechanism for what it is that the job requires. My father and I started the business about 14 years ago. He's been in the industry all of his life. He was in the Navy for 10 years. He was a Navy diver. He was part of the Sea Lab program. He built a bigger ROV in the mid-80s. And in the early 90s, he started talking about why do ROVs need to be big and cumbersome and require a lot of people, heavy handling gear, expensive. Why not make a smaller? So in a smaller ROV, you've got to package everything in a way that the ROV is still maneuverable, but still has enough power to overcome the drag of things like the tether. And then our goal was too, we want to keep it affordable. So that's where SolidWorks has been huge. We need to come up with an elegant design. We need to integrate things. We need to see how the thrusters work together and how we can get the different maneuverability and where do we put the buoyancy and what about hydrodynamics through the water. So the business started by me operating the ROVs we were making, mostly with trade shows and demonstrations. And then what happened was I started getting phone calls about, hey, you've got that ROV, could you come and do this job for me? I spent a month in the South Pacific looking for Amelia Earhart's plane. I spent a bunch of time in the Baltic helping clear World War I and World War II sea mines by delivering explosive charges. There were autonomous vehicles that are working in military ops and they go missing, and I've had to recover those. And from that experience, I'm able to come up with the ideas for A, tweaking the product, or B, developing a new product. Not being an engineer, how do I do that? Well, I gotta learn SolidWorks. This is the transponder that communicates with the top side to give you your underwater positioning. Did enough of the tutorials that I was able to start creating my parts, because once you did a few of the tutorials, it was just the product was so simple to use, it's so intuitive. I can take an assembly or a part and I can modify it simply with my basic skill set, and then my main guy Tony, he could take my rough concept, make his tweaks to give it the elegance or the manufacturability.
The idea comes to me, I develop it further, and then we can pass it back and forth. It's very intuitive, very easy to use, but it's also extremely powerful.
So one of the valuable aspects of SolidWorks is that we've got these extensive assemblies. Every time we have a new idea, we don't have to start from scratch. A classic example of that was an internal inspection of a World War I submarine, sunk in Gallipoli. They have to have an ROV that can go through the conning tower and into the submarine. Our core product wouldn't fit through the conning tower. I took SolidWorks and I drew the conning tower and then just slid our product in the center of that, so I can see on my screen exactly the parts that I have to change, and then I can give that assembly file to Tony.
I had to take the back plane and cut it off, develop the different float. These thrusters, if we would have plugged them into the existing jacks, that would have put them way out here. I moved them in and I made these little adapter plates. And typically when I have parts come back in that have been designed in SolidWorks, it's amazing how easily these assemblies go together.
This transponder is made by a British company called Tritech. They gave us a SolidWorks model. Our core product, it's a payload delivery system for other companies' products. They're all using the same SolidWorks program that we're using, so they can give us the part and we can really model it up so that it looks like it was actually conceived with that part in mind. It's got 120-degree horizontal beam width, so we have to make sure that whatever we create doesn't obstruct the view, and that makes the product look better, it makes it perform better. Typically we can help streamline costs. SeaBotix has always been a growing company. For example, we just finished our fiscal year and we were up 45%. We're an innovative company, so we're always coming up with new ideas. We're not one to stop with what we have. Now what we're going to do is we're going to make it intelligent. Rather than you pushing the stick to go from point A to point B, the ROV is going to figure out the best way to do it. We couldn't do that until we had 100% solid foundation, which is what we've been able to accomplish using SolidWorks.